Hello everyone, in this video I want to go over the idea of knowing something without actually storing it, being able to calculate something and never knowing what that something is.
Bro, what are you talking about, man?
Now, I've been using this password manager called LastPass for some time, and recently they had someone break into it and basically see their database. Now, they have measures to prevent people from actually seeing the passwords, but it still brings the question to mind, is there a better way to store passwords? And I've had this idea. And to explain it, I first need to explain a concept called password hashing. So this is mainly used in authentication systems, where you don't actually want to know what the password is, but you want to authenticate a user, for instance. And I've implemented this in a lot of my websites. So what a hashing function does is it takes in an input. Let's say I give it the input A, B, C, D, right? If I give it the input A, B, C, D, I can put it into this function. Now, first of all, why is just storing A, B, C, D in a database bad? Let's say I have a database here, right? That's going to be my little database. If I just put this A, B, C, D into the database, if someone breaks in, they're just going to be able to just dump all the users' passwords into the, just be able to see everything. So that is a bad idea. Never store passwords as plain text, because somebody's just going to steal them, right? So instead, what we can do is we can run it through a hashing function. So basically, we plug in this value here, right? Let's say this is a password, ABCD, right? And we also provide a seed. Alright, I'm just gonna give a random seed. Let's say, hello is O seed. Now, the seed should be a very, complex password, basically. But anyways, that's O seed. That's O seed. This is our value, let's just say, right? So value, we plug in a seed, we plug in a value, and then this hashing function does some crazy math in the background, right? It does some really complex math, and it basically just returns data. Almost random data. And that's the cool thing about it. It gives you data, and let's say in the form of binary, right? So let's say 0, 1, 0, 1, 1, 0, 1, 1, 1, 0, 0, 0, somehow. Something like that, right? It gives you almost random data back. But the best part, the cool thing about a hashing function is it'll always give the same output based on the same input, right? As long as you always input A, B, C, D and always input hello as the seed, you're always gonna get the same data back. And that's the cool thing about it, right? It's never gonna give you something different. It's always gonna give you the same thing. So, how do we use this? Well, let's say we want to authenticate a user, right? They make an account. They make the account with the password ABCD. We run it through the hashing function, and then we get this string of characters back. I mean, not a string of characters, well, just like this random data back, right? Now, let's store that data in a database, right? Let's store that data in a database. Now, let's say the next time they come around, they want to log into our website, right? Or they want to log into our system. They put in the same password. If they remember it, they put in the same password into our hashing function. We use our seed, and it'll always give us the same output back, right? It'll always give us the same output. And as long as that output is the same output as we stored in our database, we know that the two passwords are the same. We know that this password and this password are the same because they produce the same output. It always gives the same output with the same input. And that's the cool thing, because if a hacker goes into our database, well, they're not going to be able to do anything with this, right? That's not a password. I mean, if someone's writing their password in binary, they have bigger problems to deal with. But that's the neat thing about this. We never know what the password is, but we can always know if it's right, because the same input provides the same output, and not every output is unique, but most outputs are unique, right? If I put in ABC E instead, if I put in ABCE, it's gonna give like a completely different output, right? It's gonna be, like I said, it's almost gonna be random, but it's not random because it's the same output for every input. But it's gonna be vastly different from something like ABCD instead of ABCE, right? So different inputs provide different outputs, but the same input always gives the same output. And that's the cool thing about this, because we can verify if a user has the right password without actually ever knowing what the password is. So, how do we use this to make a password, right? And that's one of the things. Like, when I go into a new site, I want something to be able to give me a password, right? You know, like those password generators that spit out like 8 random characters, whatever. But those characters are random. What happens if I lose it? What happens when I forget that password? Right? What happens when I forget this stuff? So what I was thinking is, instead of using a password manager, we have a password hasher, right? Something that never stores what your password is, but can always calculate the same password, so you never lose it. So let's say we have this password hashing function, right? Let's say we have this password hashing function. And then we put in our seed. Now our seed is going to be our master password, right? Let's say my master password is, I'm just going to use ABCD, 1, 2, 3, 4, right? That's going to be our seed, right? Now let's throw in the seed into our hashing function. And for our value, we're going to put in the name of the service we're trying to log into. Let's say I'm trying to make a Google account. I spelled Google wrong. Let's say we're trying to make a Google account. Right? So we have a Google account, and we just plug that in as the value. Right? We plug in our seed, which is this, and we plug in our value, which is Google. And that'll give us some data back. Random data, right? Almost random data, right? That's what we're going to use to make our password. Now, you've probably seen people code, like, password generators online, right? But those all use a random function. Well, what's the difference? This is almost a random number if you think about it. We can treat this as any other random number generator, but it's always going to be the same number if we plug in the same value in the seed. And that's the cool thing, because then we can use this, and then we can generate a password based off of it. Now, a simple way to do this is, let's say we convert this binary into just decimal numbers, right? Let's say we convert 8 bits. I think that's right. Let's say we just convert that into a decimal number. We take a chunk of it and we convert it into a decimal number from like 0 to 255. Right? Because 256, that's like 2 to the 8, I think. Yeah. So a byte has, if we convert a byte to decimal, it's going to be in the range from 0 to 255. Now, we give it a list of all the possible characters, right? We provide a set of characters that we can use in a password. So let's say we have A, B, C, all the way to lowercase z. We have capital A to capital Z. We have the digits from 0 to 9, and we have some special characters, right? It's like exclamation mark, $, $sign, exponent, what other stuff is there? Ampersand, I think hashtag's one of them. I know there's 8 of them. Maybe percent. What's the last one? I think it's question mark. Alright, so we have a set of characters that we can use in a password, right? And this set of characters is 26, 52, 62, 70, right? We have 70 characters in the set of characters that we can use in a password. And let's say we want to make a password of length 16, right? A 16 character password using these special characters. Now, how do we do this? Well, let's take our first chunk, right? Let's take this first chunk of values, our first byte, right? Convert that into decimal. We get 0 to 255, right? Now, 255 mod 70, right? And if you don't know what the modulus operator is, it returns the remainder when you divide that number by 70, right? And this is actually going to be a range from 0 to 255. So it's going to be a random number from 0 to 255 inclusive, mod 70. Now, a mod can never be equal or greater than the number itself, right? If I have like 10 mod 3, that equals 1. So we get a remainder of 1 when we divide 10 by 3. But it's never going to be 3. 10 mod, like some x mod 3 is never going to be 3. It's never going to be 4. It's never going to be 5. It's always going to be 0, 1, or 2. Right? So, we take the mod 70, and that's going to give us a number from the range of 0 to 69, right? Because it's always going to be, x is always going to be less than or equal to 69, or you could also say x is always going to be less than 70, alright? So it's gonna give us a number from 0 to 69. And we can use that number to index into our character set, right? So let's say we get the number like 25, right? Now, the 25th index is gonna be Z, right? Because there's 26 letters in the alphabet, but we start counting at 0. So, let's say we get 25, we find the index, we get Z, right? Repeat the process. Do that again. We get the @ symbol this time, right? We get the @ symbol, repeat the process. Do it again. Find a value like this, mod 70, get the index into the character set, and look, oh, this time we got 2. The next time we get 0, the next time we get a capital A, the next time we get a capital H, and so on, until we have 16 characters in our password. And here's the coolest part, because all of these things we did step by step, right? All of these are just basically operations we did. If we give it the same value, and we give it the same seed, it's always going to give us the same output. It's always going to give us the same semi-random data back. It's always going to be able to turn into this. It's always going to give us the same number when modulus is applied to it. It's always going to give us the same index, and it's always going to give us the same password. So given the same inputs, we get the same password, but we never knew the password. We never need to store this password anywhere, because all of it is done mathematically, or through operations, right? We never need to know what this password is, but we always know what it is. Kinda hard to understand there, but given the same input, we always know the same output. And this means that we can, as long as we know the master password, as long as we know the seed, we can always get the same value back. We can always get the same password back. And this is my idea for a password generator. Unlike a password manager like LastPass or something like Bitwarden, we can make our own password generator that gives us the same password back based on the same master password. And all you need to do is memorize and keep secret your master password. Just make a super strong, super complicated master password. And then, since none of the sites actually know what your real password is, even if a single site gets a breach, all you need to do is just to change that password, right? And now, we have basically the equivalent of a password manager, but with none of the data being stored, right? And that's the cool thing about this. And that's about it for this for this video. It was a bit of a long one, but I hope you guys enjoyed it, and I hope to see you guys in the next video. Thanks for watching, and see you next time.